This week on 5 Minutes of Cloud, we're going to start talking about container security. So what is container security? We're really looking at a number of different factors that impact the security of the code that is either written and running inside of a container or is being deployed into a production environment in a containerized format. There are a number of aspects of this environment, but I think it really comes down at its base to a shift in how people were thinking about applications and how that impacts the ability to actually secure your application code in a way that is different than what we had done in the past when we were thinking about monolithic applications. Now, some of the things just don't change. We should still be doing static and even dynamic code analysis. This is just good practice for any code that we write. And in most cases, when people are looking at continuous integration and continuous deployment pipelines, that's exactly what they're doing. Now, the next thing that comes into play, though, is when we start thinking about code from the perspective of how we actually manage it. It's how we manage the code lifecycle, really. We start thinking about the packaging process. And containerization, one of the things that I think happens is people get a little lazy. They start saying, oh, well, I'm building this in an Ubuntu environment initially, or a Linux environment of some other nature initially, so I'll just use that container model, and I can get an Ubuntu image or a CentOS image or a RHEL image for what it matters, and I can start there, and I'll just put my code on top of that, because I know all the core libraries that I need are going to be there, and everything else that I need should be there if I then actually want to operate this. That's effectively the lazy approach. And one of the problems is that you really have exactly the same security issues that you would have within an operating system, and you put that on every single container that you deploy. And this is just a bad practice. Another problem, of course, is the fact that once we've actually decided to bundle all our resources together, we don't think about necessarily what we're doing in terms of our environment where we're running these containers. Up until probably 2 years ago, for the most part, that was a single machine running a Docker environment. Or if we were looking at a cloud target, we were probably looking at a shared container runtime environment where we would just upload our code and hope that somebody was handling the security on the back end in some reasonable fashion. Really, it wasn't clear how that was being done, but the problem, of course, is that containers themselves have some known issues in terms of how the runtime interacts with the underlying operating system kernel. And while many of those issues have been patched over the years, and I would say that in general, the interface between a container and the kernel is as secure as we can probably make it today, there are still some interactions there that are directly from an application to the running live kernel, and that creates some potential vulnerabilities, things that we might not have determined how to break today, but might come tomorrow. So there's some tools that we could implement to help secure that interface in a more effective fashion. Things like the Kata Container Project or the Google gvisor components all fit into that layer. In addition, we can start thinking more about how we actually treat our container itself. Even if we're going to stick with the Linux-based container model, when we actually store that into a repository or into a container registry, we can actually start thinking about checking the code at that point. So even if our developers didn't do good dynamic and static checking as they're developing their application, at least we can compare their system and all of the different libraries and components within that system for vulnerabilities at the time of uploading it into a registry. Now, this doesn't necessarily make things more secure because it's just going to give you a report of where there are potential vulnerabilities, where there are outstanding CVEs, but it gets us one step closer. And finally, when we do think about where we're deploying, if we want to actually start limiting that scope of security impact, if we want to thinking about how our containers are being tied together, we can start thinking about both the runtime environment. So most clouds today provide a Kubernetes-based model. Either you can run your own Kubernetes on top of VMs, or you can even use their control plane and your own VMs. And I think that's the important part. The underlying VM becomes your own in a Kubernetes-based deployment environment. But then we can also start thinking about how those different services interact. If it's still effectively a fairly monolithic app, one application, one database, maybe there's not a whole lot that needs to be done there, but we can actually start securing the communication between these resources using tools like service meshes, specifically either an Istio or maybe Linkerd are the two, I think, front runners in the space today, to provide communication security between the different services and resources. Now, we still have to think about how traffic is coming into our environment and how we're limiting that itself. Also done through a service mesh, we can do that through effectively a proxy. So we have only one ingress path, but we still have to think about Stack Overflow issues and all these other sorts of things that come in through that one communications paradigm. But at least it's now been secured. It's running over SSL. We've done as much as we can beyond what the application itself needs to deal with. So there's a lot going on in the security space, from static and dynamic code checking, that's just standard container or not. Registry-based scanning is a very powerful tool for helping to at least understand what vulnerabilities you may be exposed to. Running a Kubernetes environment, either your own or in the cloud, but on your own VMs, at least gives you that VM layer of security. If you are running your own environment, it's possible that you can also add in the layer of something like Kata containers or gvisor to provide additional runtime security, so that if a container is somehow compromised, if that process is compromised, you're limiting the impact on the rest of your system in that particular systems model. And of course, securing the communication, not just outside of the cluster, but across the different components of the cluster, a very powerful way of continuing to add another layer of security enhancement, especially if you actually start thinking about using that as a site-to-site capability and interaction as well. This has been Robert Starmer, bringing you another episode of 5 Minutes of Cloud. Don't forget to subscribe, and if you haven't already, check out our learning catalog. We're increasing the number of classes available to our end users to really start to understand how to operate and manage containers and containerized applications in this new development paradigm. We really look forward to having you join us on our next episode.